Yes, you are allowed to use a note card, so please one page only. So if you like to print the formula sheet, then it counts as one piece of paper. You can write your notes on this formula sheet, but or the formula sheet will be in the instruction field as the last time, so you don't have actually to print it. So you can write your own notes as you wish. So the exam will be open from 8 a.m. to 12 p.m. So 4 hours. If this time is impossible for you, we can reschedule. Um, but I try to keep the time that was scheduled for the lecture, and I don't want to keep it for the whole day. Okay, we will see how it will work this time. Last time we had so many exceptions in the last month. Okay, if there are no other questions, we will start with our review. I think we have a lot of time, so you can ask question if you need during the review. Okay, the first question is pretty simple. So write the percent as a decimal. Okay, there was only one over here, but in the reviewer I have two examples. So for example, the percent is 9.21 in a decimal form. We move decimal point 2 places to the left and get 0.0921. Yes, this the, or you can write also this 0, that doesn't matter. It will accept both. I have noticed that some students were confused in how I write the correct answer. So in some problems that you can read that it accepts only the exact answer. In some problems that there was it was written. There were written only the first digits and the last not written, and it was written contains this or that. So I have seen some students have asked me why the answer was without the last digit. So that I have used this contain feature for answers when the rounding was this was possible to round it. That student rounded different, and it would accept different answers for the last digits, but it doesn't matter. It doesn't mean that you need only type one digit. So if it tells round to the second decimal, you must type to the decimals. I don't use this contain feature anymore. So in some answers you can see such a thing for 0, so 0 is in parentheses and then question mark. It means that the computer will count it correct whether you type the 0 or you don't type the 0. Yes, this is just how the Blackboard grading works. For example, this 0 in front before the point, you can type it or you don't type it, and that's all. So, okay, the second example, 54.2%. So the same thing, to write it in decimal form, we moved decimal point 2 places to the left and we get 0.542. That's all. Okay, 5% notation. This is a little bit more difficult. We have 8 divided by 32, so we need to divide. So, and we get it in decimal form, 0.25, but the answer must be given in percent. So we move decimal point to the right, and it is 25%. So I think all questions will be without rounding. So if you get more digits, then you just keep more digits. So let me say, so for example, if you get 1024, so say you want to find this 1 over 1024, this is also the exact fraction, 0.007812. You don't have so long, but still there is nothing about rounding, so you don't round here. So you just move decimal point 2 places to the right, and it is 0.78125%. Okay. Okay, we move on to the next question. Compound interest formula. Use the formula for computing future value using compound interest. So what is the formula? The formula is future value equals principal times 1 plus r over m raised to the power mt. So, and what data we have here? At the end of 16 years, so t is 16. The principal amount, P, is 40,000. Deposit in the account with interest rate 5.25%. We need it in decimal form, so 0.0525, and compounded daily. Daily, so every day. How many days a year do we have? We have usually 365, so use 365 here. Okay, and in this problem you will give your answer in 3 separate blanks, $1,000 and cents, and so at least, so if you round it incorrectly, you should get $1,000 correct, maybe. Okay, so it is very important for this test to take a photo of your shown work and to upload it with the last problem. So the total points are for this test, I think 120. So 40 points is for uploaded shown work. I record every lecture, and all the lectures can be found on Blackboard. If so, if you do not know how to find the recording, please email me, or I will forward you the old email when I showed how to find the recordings. Okay. Okay, so I repeat, it is very, very important to show your work, especially for these problems with calculating, because often you can get only partial grade. So if you do not show your work, or as it was previously on paper exam, I see the students are writing something with the pencil and then erasing everything. Your scratch paper is your chance to get a partial credit that can be up to 90%. So even if the answer is completely wrong, so your scratch paper is very important. Okay, everything that you have done. Okay, so we have all our data. Now we can use the formula. A equals 40,000 multiplied by 1 plus 0.0525 over 365, and raised to the power 365 times t times 16. So I put this in parentheses so that if you use your in-hand calculator, you don't forget to put it in parentheses. Okay, I will use my decimals as usual, and then I highly recommend you to use it too, because here you don't need to round the intermediate steps. Yes, so your shown work your shown work is the formulas, the substitution. You don't have to write down the intermediate step if you use decimals or another online calculator. There are many. So if you use small in-hand calculator, your rounding on intermediate steps is very important, because this is often the reason for wrong answer. Okay, that's why if you solve it step by step, you can use your you can write the intermediate answer on the paper. Okay, so first we find 0.0525 divided by 365. So, okay. Once I got a question, so if your calculator shows something like this, what does it mean? So I got point. So if I use the decimal system, I don't care about this because it is intermediate result and I don't need it. So, but if you use solve it step by step and you got something, oops, okay, 1, 4, 3, 8, 3, 6, 3, 5, 6. Okay, and multiplied by 10 to minus 4 to negative 4. What does it mean? It actually means that your decimal point must be moved 4 places to the left. So it means that you have point and then 0, 0, 0, and then your 1. So the original place for the point was here, and we moved it 4 places to the left. And then 4, 3, 8, and so on. This is how you read the scientific notation. So this is in the situation that happens in the situation when the number is very, very small or very, very big. Then your calculator gives the answer in this form. Okay, but I actually need to add this to 1. Okay, and it is, yes, the decimal point. The decimal point is here in front of 1. This negative 4 shows how many zeros. So how many? So for example, if you have 1.25 times 10 to the 5th, it means that you move your decimal point 5 places to the right. 25, and then the 2 places, and then you add the 3 zeros. This is your actual number, and calculator uses scientific notation as more convenient. So, and if you have 1.25 times 10 to the power negative 3, it means that the decimal point is actually 3 places to the left from this. So 125 and 1, 2, 3. So we need 0, 0, and this is actually this number. Okay. You are welcome. Okay. If you always miss participation credit, then I do not count your as attendant. If you miss the participation credit, you should email me and we will talk about this. So, because I have several students who never answer participation credit and I mark them absent as not participating. Okay. So, okay, we return to our formula. 1 plus, so now we have this is the expression in parentheses. Okay, these are the parentheses, and we raise it to the power, which so here we need another parenthesis for 365 multiplied by 16. Okay, this is the next intermediate answer. So if this is the expression in the parentheses raised to the power, and the last step. So if you work step by step, this is the first, second, then raising to the power is the third operation, and then the fourth is multiplication. So we multiply by 40,000. So, and then we get the answer. So, and then we read how the answer must be given. So thousands, dollars, and cents, and we round to the nearest cent. So 92,649.0. Then we have 8. After 8 we have 2, so we round down 0.8. So we will type here 92, here 649, and here 0.0. So you had already the problems like this on quizzes, so you know how it works. So it must be, you must be fine with this. This is usually toward the end of the lecture, although I'm trying to move to the middle to the middle of the lecture. I mean the quiz. Okay, then if you don't have any questions to this second problem, we move on to the next. Unpaid balance method. I usually have both methods, unpaid balance and average daily, but so we have such a hard time in the middle of this time between the first second exam that I removed the average daily balance and left this one only, the unpaid balance method. So you have to fill 3 blanks, and these blanks are in the same order how you solve the problem normally. They must help you to come to the correct answer in the end. So when you use unpaid balance method, you first find the finance charge based on the starting balance, on the previous month balance. Yes, you first find previous month finance charge. We take 310 multiplied by RT. R is 0.28, and we use 1/12 for T. So we multiply by 1/12, which is the same as dividing by 12. Okay. 310 times 0.28 divided by 12. And we round to the nearest cent. It's approximately 7.23. And we write this in the first blank. This is the finance charge based on the previous month balance, 7.23. Okay, now the balance at the end of the month. Don't forget to add this finance charge to the balance. So the balance, or you can use P for this, will be the starting balance 310, finance charge 723. Then we look to the table. We charged our credit card by 115. Then we made a payment of 220, so we reduced our debt, so we subtract the payment. Then we return something, so that it also reduces the balance on the credit card. So we subtract 29, and then we charge it again. So we increase our debt. So we add 189. Let us find this balance. So 310 plus 7.23. Then we charge, so plus 115. Made a payment, subtract 220, return, subtract 29, charged, so plus 189. Okay, the balance is 372.23. And the last thing, the second finance charge that we must find. So this is the finance charge based on September adjustment, but it will appear on October bill. Okay, so this use the same formula, PRT or BRT. So, but instead of previous month's balance, so we take the previous, but for this, the previous month will be the September. So we take the September balance, 372.23, and multiply by the same RT. Interest rate, 28 divided by 12. It is the same as multiplying by 1/12. Okay, so we take the answer from the previous step, multiply by 0.28 and divide by 12. And this is the finance charge that will appear on the next month bill, 8.6. So we have 8 of that. After the 8, we have 5. So we round up. Instead of 8, we have 9. 869. This. Okay, I don't really understand what is it all about. Okay, so any questions to this kind of problem? No, we round as usual. We do not round down. So in the balance method, we round. Is it written here somewhere? I think it will be written somewhere in the body of the problem. So round to the nearest cent. I think I have added this to the body of the problem. So here you just round as needed. So 5, 6, 7, 8, 9, round up, and so on. This is a good question. So I kept one more digit in previously, but I have not noticed that it could change the final answer. So you see, on this step, we should round to the nearest cent. If we have here, so let me see. If we have there another 3, so like this, then it will be added to the balance. So it does not, this additional 3 will not change the answer for the second part, for B. And then if you would have this additional 3 here, this is the 6th digit. Your answer contains 3 digits. Yes. So if you keep only 5 digits, the 6th digit would not change the answer. So actually, you don't need this digit in the most cases. Maybe you can imagine such a situation when your final balance is so close to zero, so it's about $2 or $3 your final, so you paid off your all your balance, and your final balance is about $2-3. Then maybe this last the fourth digit will influence, we can influence the answer, but we don't have this in our example, so usually you don't need more than cents, more than 2 digits in it cannot influence our answer. Okay. So, and the next problem, find the you're welcome. Find the monthly payment needed to have a sinking fund accumulate the future value of 54,000. Assume the yearly interest rate of 7.5%, and the time is 20 years, and the interest is compounded monthly. Okay, sinking fund is the same as annuity. So we use annuity formula. Regular payment is multiplied by this fraction, 1 plus r over m raised to the power mt minus 1 divided by r over m. Okay, so we want to find monthly payment. In this kind of problem, we round up. So when we solve for something on the right side of the long formula, so we round up, but it is also mentioned in the problem itself. So we have the future value A. A is 54,000. The yearly interest rate R is 7.5% or 0.075, and the time is 20. Okay, what else do we need? We need also M. M is 12 because the compounding is done monthly. Okay. So we can write it in this formula with substitutions. Oh, sorry, we know A. We know A, it is 54,000. We don't know R. 1 plus 0.075 over 12 raised to the power 12 times 20 minus 1, so this is in parentheses, and divided by 0.075 over 12. So I think in this problem you don't have to round r over m, 0.075, because I never get the correct answers for if I have this rounded. Okay, but please, if you have three digits here or 4 digits, don't make them 2 digits. Do not round to 663. Okay, it's very important. Okay, so let us find the expression on the right. First, we want to find r over m plus 1, 0.075 over 12 plus 1. Then we raise it to the power, and this is expression we will take in the parentheses, 12 times 20. So I like to make it in my head, but the experience shows that it is better to prove every step with a calculator. So minus 1, so according to our formula, this is the value in the numerator. And then we divide this by r over m, which is, okay, you can type the formula again, or we take it from the top from the previous line, 0.00625. Okay, so we got that 54,000 equal to R times 553.73. So let us take two more digits just in case, because our answer, our regular payment will contain maybe 5 digits. Yes, so maybe somewhat hundreds and cents. Yes, 5 digits. So we need more for intermediate answers. So 0.7. Okay, and now we solve this equation for R. So we want to isolate R on the right. So we must divide by this 553 point and so on the right and on the left. So it will disappear on the right, and we have R equal to 54,000 divided by 553.7307, and this is 54,000 divided, I use the answer feature here, divided by answer. This is 97.52. Okay, we must round up, but it is actually 0. So I think I'm not sure how they should it be 52 or 97.53, but I will accept both versions as correct. In theory, one must round up, but we have 0 here, so I don't know exactly how they do it, and I will accept both answers in this case. Okay, so let's just check. Okay, record. Any questions to this problem? Okay, then we move on to the next one from 8.5. On the midterms, we usually have one question to every section of the book. So from 8.5, we have the longest formula, but this formula is not really used. That's why the table is more used in the real life. So that's why we have a question with the table. Yes. Okay, so a borrower has taken a 10 years mortgage for 35,000 and the annual interest rate is 8%. Use the table of monthly payment for 1,000 loan to find the monthly payment on this mortgage. Okay, and this is pretty simple from the point of view of mathematics. Important is that you understand how to do it. So we have 35,000. The mortgage is 35,000. For 1,000, the payment for 1,000 is given in the table. Let us find the correct line. So we have 8%, 10 years. 8%, 10 years. The intersection is here. So we pay 12.13 for 1,000. So we will pay 12.13 for times 35 for 35,000, and that's all. 12.13, we don't need any other formula, times 35. This is the regular payment for 24.55. And the second question, find the total interest paid on the loan. Okay, so we pay 424.55 every month. every month during, so times 12, during 10 years times 10. So in 10 years, you will pay this times 12 times 10, 50,946. Yes, you will pay 50,946. So instead of 35,000. So if you subtract 35,000, then you will get the interest. So what you will pay for interest. Yes. So 50,000 minus 35,000. The interest paid, the total interest paid will be 15,946. And here you don't have any rounding. Yes. You just type the answer you got. Let us, the part 2, assume that the borrower has decided to pay a down payment of 15,000. So the down payment, so from 35,000, we subtract this 15,000, so the actual loan is 20,000. This is the loan. So, and then when the loan is less, then the borrower takes this loan for 3 years, but with the same percentage. So now we are by 3 years. So change the color. Now we are by 3 years, but the same 8%. We take the loan for 20,000 loan. We multiply 20 by the payment, regular payment for 1,000, 31.34. So 3 years. Okay, we do the same steps. So 20 times 31.34. The regular payment will be 626.80 or 8.8 or $626.80. And we can find the interest, the total interest paid. So this regular payment will be paid every month during 3 years. So then the total money that you will pay will be 22,564.8. And the loan actually was 20,000. So if you subtract, you will find the total interest paid in this situation will be only $2,565.80. You see the difference? Yes. Any questions to this problem? Okay. Let us move on to the next problem. This is, so we have finished with chapter 8, and the next is the chapter from chapter 10. And first, the problem with Hamilton apportionment. So we have 4 city districts, and we distribute 22 council seats, 22 seats. So, and here also I will ask you to show the intermediate steps here. Yes, it doesn't make the problem more difficult when I ask something in the middle. It just make you to show your intermediate results here. Okay, when we use Hamilton method, the first thing we do, we find the total population and the percentage. So either you find the percentage of every region, every district, or you find the standard divisor. Maybe it is shorter with the standard divisor. So let us find the total. 3420 plus 8850 plus 1760 plus 6970. Okay, total is 21,000. Good. So we can find standard divisor. So it makes it quicker to work with standard divisor. Will be 21,000 divided by the number of seats to distribute. 22. So we divide the answer by 22, the standard divisor. So, and here how many digits do we need? Actually, for standard quarters will be a number plus 2 decimals. So here, 2 decimals. So we will have 3 digits, yes? The number of seats, or maybe 2 digits when the seats, there are more than 10 seats, 2 seats and 2 digits after the 2 digits before the point, 2 digits after the point. So we need somewhat 5, at most 5 digits. Yes, so let us keep 2 digits after the point for standard divisor, 954.55, the standard divisor. So to find the standard quarter, we divide the population of each district, 3420, by the standard divisor, 954.55. Okay. So the first 3420 divided by 954.55. Okay. So the standard quarter, is 3.50. Sorry, it was 3.58. Yes, I said if you prefer to use Hamilton method in another way, so as we have learned it in the first section, you can, for North, for example, North, if you like it, you can use this. So 3420 divided by 21,000 and then multiply by 22. You must get the same answer. It must be the same 3.58. And this is also 3.58. This is up to you. How do you use the standard divisor or do you use the first method? And I will also, in the formula sheet, I will give you both. Boxes with explaining the first way and the second way in case you forget. Okay, so this was the standard quarter for North. For South, we use 8850, the population. So you see why I use this method. I just change the numerator because denominator is the same, the standard denominator for all districts. So 9.27. So we keep only 2 digits here. We don't need more. And the east 1716. 1. Oops. Sorry. So okay, 1.84. And then the west 6970. And we have here 7.30. Okay. So in the next step so we have found standard quotas. The next step in Hamilton apportionment method is to apportion the lower quota or the integer part. So we apportion the integer parts. So it will be 3 for north, 9 for south, 1 for east, and 7 for west. So let us find the sum. 9 plus 1 is 10, 3 plus 7, 10, so we have 20. So we have to distribute 2 extra seats. And in the Hamilton apportionment method, so let me stop sharing this and share. Wait a minute. Doesn't. Okay, let me share this and let us make the pool. Let us make the pool. Let us choose who will get these 2 extra representative. You should think about it now when I type the questions. Okay, so you remember, wait a minute, type, wait, no, okay, south and west, and one more, east and west. Okay, oh, I need one more. And okay, so please choose which two districts must get the extra representative seats. So extra seats. You remember Hamilton method? We use the decimal part of the standard quotas to choose those who deserve extra seats. I see you're answering mostly correct. So please choose which 2 districts get extra seats. So look at the decimal part. The greater the decimal part, the more chances to get the new seat. If you don't know the answer, choose it randomly because I'm closing the pool soon. Please choose one of the answers. Okay. I'm a little bit confused. So many students don't know how to use the pool today. Okay, I close the pool. Okay. Let us return to the whole screen. Okay, so we got 20, so 2 extra seats, and we have the decimal parts 58, 27, 84, and 30. We must choose the 2 greatest decimal parts, and they are 84 and 58. 84 is the greatest one. The next greatest is 58. It means that north and east get extra seats. Now, when we add this, we will get 22. Okay, north gets 4 seats, south 9 seats, east 2 seats, and west 7 seats. Do you have any questions to this method? Okay, so you will have to find standard quarters and then to distribute the seats. So the given number of seats. The next problem is from 10.2, Huntington Hill apportionment principle. So it will be similar a little bit to the problem on the quiz on Monday. I remind you that this quiz has 3 attempts so that you can fix it if you don't understand something. I just don't want you to get surprised on the exam. Okay, so given the population of 3 states, apportion 9 representatives to the states using Huntington-Hill apportionment principle. Specify the order in which the representatives will be assigned. Begin by giving 1 seat to each state. Okay, and so, and this actually a real population. So in this example from 2019, and on the test from 2020, the real population to make the numbers convenient, they are given in hundreds, thousands. So just take these numbers as they are given in the problem and use them for calculating Huntington Hill numbers. You have the table of Huntington Hill numbers partially filled. On the test, the one line will be missing. So, and here I have more missing blanks just to give you more practice for this. So first we must fill out the table. Okay, in the first line, the current number of representatives is 1. In the second line, it is 2. And you know Huntington Hill number is population of the state x squared divided by current number. So this is n in this table, and divided by n plus 1. Okay, so for the second line, it will be divided by 2 and divided by 3. 2 plus 1 is 3. Okay, so for the state A, 19.34 squared divided by 2 and by 3. And we must round it to the nearest cent. Oh, sorry, not cent, to the second decimal. 62.3. Then we have 3 9, so we round up because it is 9, but we round as usual in this problem, 3.3. Okay, the next state B, we have the same denominator. Actually, we change only the numerator. Is 17.92. So the Huntington Hill number 53.52. Okay, let me see. So if you round up 60 or 64. So you have to round to the Huntington Hill numbers, yes, because they are not exact and there will be big numbers. You don't need the whole number, all these decimals. Okay. Okay. I don't remember what so let us return to A, 19.34 squared divided by 2 and by 3. Oh, sorry, you are correct, it was 4. Although it doesn't matter. And this, so 4. Okay, but you are correct, it was 34, I'm sorry. Okay, and the last one is 42.18 squared divided by the same 2 and 3. So, and here we have 296.5255 is rounded up, so we have 3 here. Okay, and let us just for more training find the Huntington Hill number for the last line. So it will be population squared divided by present apportionment 5 times future apportionment 6. Okay, for C, we will have 5 times 6, 42.18 squared divided by 5 and 6, 59.31. And for state B, 17.92 divided by 5 squared divided by 5 divided by 6 will be 10.70. So after 0 we have 4, that's why we round down. Okay, this is the first part. The second part, use these Huntington Hill numbers to apportion how many? So 9 representatives. Okay, so we divide by 5 and 6 because it's the definition of Huntington Hill number, the square of population divided by the number of representatives in this line. So the number of representatives in this line is 5. This is n. In this line, n equals 5, and that line, n equals 6. Yes, the current number of representatives. And the second, so you see in the formula for, so this is the Huntington Hill number. This is the formula for Huntington Hill number. So, and in denominator we have n, the current number of representatives, and we have n plus 1. So the current number plus 1. That's why. Okay, so now we have to apportion the represent. Why from 4 to 9? Because first we apportion the first 3 representatives, we apportion in the beginning because Every state must have at least one. So first we apportion one representative to every state, and then we look on the table of Huntington Hill numbers to distribute the rest. Okay, so the fourth, and you will have to type them in this order. The fourth goes to the state with the greatest Huntington Hill number. You look on the top line, the greatest is 889. So the fourth goes to C, the state C. Fifth, we look at the table so we cross off 889. We look at the other numbers. What number is the next? Be careful. So the next is 296. So the fifth goes to the state C as well. We look at the rest numbers. So we have 187 here, 161, 187. So the sixth goes to A. Okay. The seventh. We look at the numbers that we have now. We have 160, 148. 160 is greater than 148, so the seventh goes to B. The eighth. Okay, what do we have now? 62, 53, 148. So the eighth representative goes to C again, and the ninth. So look on the numbers that we have now. 62, 53, 88. 88 is the greatest one, the greatest number from those that we have left. So the ninth goes to C again. Okay, this is how we will apportion the representatives in that order we will apportion representative in Huntington Hill number method. Okay, any questions? Okay, move on to the next problem. So we have two states with their population given in thousand and the representation in the House of Representatives, and we want to calculate average constituency for each state. So it will be given how to round in the problem. So I need a calculator. Okay, so Ohio. The average constituency of Ohio, 11,689 divided by 16. So how many people is represented by one representative? 11,689 divided by 16. So I think we will round to the second decimal, so 730.56. We have two after that, so 56. Okay, and then Louisiana, the same. We take the population, 4649 divided by 6. So, and we get the average constituency, 774.83. Which state is more poorly represented? Okay, more poorly means more people for one representative. Yes, we have 730 and 774. Of course, 774 is greater than 730. That's why Louisiana is more poorly represented. Okay, then the absolute unfairness and relative unfairness. I decided to ask you for both because if I ask for one of them, then I always have students who mixed up and have found the wrong one. Okay, just found both of them. So first is the absolute unfairness is just the difference, 774.83. So we take these numbers rounded to the second digit, subtract 730.56. Okay, this is the absolute unfairness, 44.27. And the relative unfairness, so if you forgot what you must divide by, you will have the formulas, and it will remind you that you divide by the smallest one. You divide by smallest constituency, 730.56. Okay, and here in the relative unfairness, you must keep 3 digits, because for some states the apportionment is so fair that the unfairness is has zeros in the first 2 digits, so we must keep at least 3. 0, 6, and we have 0, but after the 0 there is 5, so we round up. We choose 1 here. Okay, 0.061 is a relative unfairness. Any questions to this? I think not, it's pretty simple. Okay, and I forgot to add I didn't add it to the last questions to the email, to the yesterday email, so there will be one short question for 5 points with consumer price index. The consumer price index is a measure of inflation obtained by comparing current prices with base prices. So the inflation rate, and also if you already made the review assignment, I have changed the question there because the first one was too short. So in the review assignment, I have changed. I have added another option for this question. Okay, so obtained by comparing current prices with base prices, the inflation rate is equal to the percent of change in CPI between the 2 years. Below are consumer price indexes for selected years. Okay, calculate the inflation rate from 1990 to 2010. Not the inflation, the inflation rate. So this is like a percent of change. So you take the CPI from 2010, subtract the CPI from 1990, and divide by the smallest one, but base, divide by base 127. So 217 minus 127 and divide, so don't forget parentheses when you have a difference of sum, and divided by the smaller ones, 127. So the answer must be given in percent. Yes, so we got the decimal. Then we go down with the decimal. Yes, 0.7087, and we want to give it in percent, so we move the decimal point to the right. 70.87%, the inflation rate. So if a gallon of milk costs $2.78 in 1990, use the inflation rate from part A to estimate the cost of a gallon of milk in 2010. So the price in 2010, we take the old price, 278, and multiply it by the fraction of 2 CPIs. So 2010 is 217, and 1990, 127. 2.78 times 217 over 127. So if the inflation rate for milk would be the same as the average, then the gallon of milk would cost so much. But you know, the milk prices fall very much, and they will low down, and and actually we use CPI for different products, different CPIs. Okay, so what kind of So 7087 would round to 71%, but here is written round to two decimal places. Two decimal places are two places after the decimal point. Okay. So okay, to try to use part B. But part B, the answer is in dollars. Oh, what? The formula for inflation rate, not for inflation. So this is the percent of change formula. Percent of change formula, correct, Mary? Yes. CPI minus CPI base. Base divided by CPI base. So base is the first year. So we have here 2010 and 1990. So this is our base, and this percent of rate equation will also tell us we have round up. Yes, I will check that. I will check it again that every problem has this specification. So round up or round or just around to two decimal places. Yes, I will check that. So there will be one problem that will not tell you to round, because there is no rounding for this 8.5 problem, because then you have a regular payment for 1,000 that is already rounded. You just use these numbers and multiply by number of thousand, which doesn't require any rounding. Okay, so we have 5 more minutes, but we have actually finished with the review. So if you have any questions, I just remind you to write down what you do in your notes, on your scratch paper, and upload the scratch paper. If you have some problems with uploading, sometimes the exam freeze in the last minute, or something happened when you I think it happens when you try to attach the wrong file. So some student, instead of a file, give me some link that is very hard to open. And yes, 8 questions plus bonus. Yes, and some students try to attach some link or use another file types. I recommend to use this combine PDF link. So combine PDF.com. It is a secure site that uses encryption. So if you put your file, or if you have maybe for this exam you will have many pictures, yes, many pages. So you have a lot of work here. It's a difficult exam. So just pull your pages into this combined PDF site, and it will make one PDF. Then you will be on the secure side with this. You will have only one file. It is easy to open for me, and there's usually no trouble with the upload. So just don't forget that you will have to leave about 5 minutes for this at the end of your exam. Don't wait at the last minute. You have 90 minutes. from this 90 minutes, last 5 minutes must be saved for the file upload. Okay, so you need a lot of, you have a lot to do. Take a photo, convert it, so to email it to your, okay, from your phone to your computer, then open your email, maybe combine the files to convert them and PDF. It's actually everything is very quick. It can be done very quickly, but who knows how long will your email, sometimes the email works weird. So in case that you have not uploaded your file or you don't know whether it was uploaded or not, you can email it to me as well. Okay. So any other questions? So the exam, I told you already, the exam will be open from 8 to 12, but if you have trouble with this site, I can make some exceptions, but I think the morning time is the best for taking the exam, and you are used to have a lecture this time, so the most student must be fine with this time. So, any other questions? So if you don't have questions, then you're free for today. Thank you so much. Log to my Zoom if you have any question. The Zoom link is in my signature to every email. Just press the link, and if I'm available, I will open the window. If I'm not, I will email you when I will be next available. Okay? Have a great day, and bye.